In this video, I'm going to summarize what we've done with the 6 trigonometric ratios. And we started in 1.3 with a definition. If you're given a circle with a radius of r and you take some point xy on that circle, these are how we define the 6 trigonometric ratios. So if we were finding them for this problem here, what we would have done is first found the radius, which really is just a result of making a right triangle right here and using Pythagorean theorem to solve for r. But we're just going to use the formula. So x here is 3. Let me go ahead and write x equals 3, y equals -4. And so this would be 3 squared plus -4 squared. We're going to get the square root of 9 plus 16, which is the square root of 25, or 5. And so the sine of this angle is y over r, which would be -4 over 5. And the cosine would be x over r. X here is 3, so that would be 3 over 5. And then the tangent is y over x, which would be -4 over 3. And then the nice thing is these are each the reciprocals of the above. And so all we have to do is flip these. This is -5/4. Secant will be 5/3. And cotangent will be -3/4. And so that's how we first started. Then we got into section, I think it was 2.1, and our focus was on triangles. And actually, before we do that, I just want to mention something really quickly. I normally like to arrange my ratios this way. So sine is y over r, and cosine is x over r. We know that tangent is sine over cosine. If you put y over r over x over r, that reduces to y over x. And there you go, y over x. And then these are just the reciprocals, so I just flipped each of these to get the reciprocal ratios. All right, so let's go ahead to where I was just going, section 2.1. So we next learned about right triangles, or focused on right triangles. And so we talked in terms of the opposite side, the adjacent side, and the hypotenuse, which are labeled here. Sometimes people confuse the adjacent and the hypotenuse side. Just remember the hypotenuse is the longest side, and the adjacent side is the other side of the angle. All right, so to remember this, there is an acronym that you probably saw. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is opposite over adjacent. And so that's how we use SOHCAHTOA. But again, you can see you have opposite over hypotenuse and adjacent over hypotenuse, and the tangent, remember, is sine over cosine. It ends up being the opposite side over the adjacent side. And then these are the reciprocals of those. And so that just makes it a little bit easier for me to remember. Let's go to our special triangles next. And what I want to do next is focus on how we can create the table for 30 degrees, 45 degrees, and 60 degrees, which are our common angles. So what we looked at, I think this was also in section 2.1, maybe 2.2, but we looked at the 45 degree triangle, and using Pythagorean theorem, if you make each of the legs 1, you find that the hypotenuse is the square root of 2. In fact, it doesn't matter what you call these two legs other than they're going to be equal. You'll end up with whatever this side is times the square root of 2. So if this had been 3 on each side, this would be 3 square roots of 2. And so that's the 45, 90. The other one we need to know is the 30, 60, 90 degree triangle, which is basically half of the equilateral triangle. And what you find, again using Pythagorean theorem, is if you make the shorter side 1 and this side square root of 3, that you end up getting a hypotenuse of 2. Actually, you can go back and see how we got these sides, but what really matters here is knowing the relationship. The smaller leg, if you double that, you get the hypotenuse. And if you take the smaller leg and multiply it by the square root of 3, you get the length of the longer leg. Alright, so these are the two special triangles that you should get to know if you don't already know them. So here, if I'm going to go ahead and find the sine of 30, 45, and 60 degrees. So for 45 degrees, we'll use this angle here. We know it's opposite over hypotenuse, so the opposite side is 1 over the hypotenuse, which is the square root of 2. To rationalize the denominator, we multiply by the square root of 2. That gives us 2. To make it legal, we got to do the same thing to the numerator. So all we're doing is multiplying 1 over the square root of 2 by something that's equal to 1. And 1 times square root of 2, we get square root of 2 over 2. For sine of 30 degrees, that's this angle here. Again, it's opposite over hypotenuse. That would be 1/2. And for 60 degrees, opposite over hypotenuse, that would be square root of 3 over 2. And so there's those three angles. Or I should say ratios. Let's move to the table now. I'm going to have to adjust my camera here. I apologize for the shadows. I don't really, in the room that I'm working in, I just don't have any way to get around it. So you can see this is the table that you need to get to know. You should, or I should say, one of the ways to learn the ratios is to get to know how to construct this table pretty quickly. Some people memorize it, but it's really pretty easy to construct, and I'm going to go ahead and do that. We already found that the sine of 30 degrees is 1/2. The sine of 45 degrees is square root of 2 over 2. And the sine of 60 degrees is the square root of 3 over 2. And, oops, let me check something here. Alright, so we learned about the reciprocal identities in section 1.4 and the cofunction identities, that was in section 2.1. So we know that if the sine of 30 degrees is 1/2, that the cosine of 60 degrees would also be 1/2, because notice 60 and 30 is 90. Or you could say this 90 minus 30 degrees, that gives us the 60 degrees. So similarly, if the sine of 45 degrees is square root of 2 over 2, then using the cofunction, we know that the cosine of 45 degrees, well, 90 minus 45 is 45, and again, notice 45 and 45 add to 90 is also square root of 2 over 2. And if the sine of 60 degrees is the square root of 3 over 2, we know the cosine of 30 degrees will be the square root of 3 over 2. Let's move on to tangent. We know that the tangent of 30 degrees will equal the sine over the cosine of 30 degrees. So in this case, that's 1/2 over the square root of 3 over 2. When you simplify this, you get 1 over square root of 3. And when you rationalize that, you get the square root of 3 over 3. So if the tangent of 30 degrees is the square root of 3 over 3, we know that the cotangent of, it'd be 60 degrees, would be the square root of 3 over 3 as well. Let's look at tangent of 45 degrees. Well, it's going to be sine over cosine. They're both the same, and so we're going to get 1. And we know that these are reciprocals. Reciprocal of 1 is 1. And then let's go to tangent of 60 degrees. Well, it would be the same, well, it'd be similar. It'd be tangent of 60 degrees would be sine over cosine of 60 degrees. So this would just be flipped, what we have above. It'll be square root of 3 over 2 over 1/2. So square root of 3 over 1, which is square root of 3. And that means that the cotangent, the cofunction of 30 degrees, again 30 and 60 is 90, would also be the square root of 3. We know secant is the reciprocal of cosine, so we're going to have to flip square root of 3 over 2, so 2 over square root of 3. When we rationalize that, we get 2 square roots of 3 over 3. That means that the cosecant of 60 degrees would be the same. Let's see, 1 over cosine, that would be 2 over the square root of 2. And actually, remember, this was also cosine when we started. It was 1 over the square root of 2. It's actually easier to work with that. And then remember, we rationalized it to get square root of 2 over 2. If you flip this, you just get the square root of 2. And so the cosecant of 45 degrees will also be the square root of 2. And then, let's see, for 60 degrees, we're going to have to flip the cosine 1/2, it becomes 2. And so the cosecant of 30 degrees should also be 2. And so that's how you can create that table pretty quickly. And I mean, the more you use them, the more you get to know them. Let's go ahead and move on to radians. So, or I'm sorry, before we do that, I wanted to do a problem. And I forgot to get this set up. So, if you were asked to find the trigonometric ratios for 300 degrees, how would you do that? Well, you'd get on the unit circle, or I'm sorry, on the xy axis, you draw a circle, and 300 degrees, well, think about this. This would be 90, 180, 270, another 30 puts you right here. So this is basically 30 degrees here. That makes this 60 degrees. And actually what I really want to use is that 60-degree angle as my reference angle. So here's my point. And I'm going to make a triangle with the x-axis. And I'm going to use my 30, 60, 90-degree triangle. So remember, we want the hypotenuse to be 2, the smaller leg to be 1, and the longer leg to be the square root of 3. And so this point, let's see, notice x would be a positive 1, and y, since we're going down, would be negative, the square root of 3. And so when we find our 6 ratios, for the sine of 300 degrees, it would be y over r, or that would be square root of 3 over 2. The cosine of 300 degrees would be x over r, which is 1 over 2, or 1/2. And tangent of 300 degrees, well, that's just going to be, I mean, you could do y over x, or you can, you know it's sine over cosine, that'd be square root of 3 over 1, or just the square root of 3. So you can use the values here, or you can just use what I just did with the reciprocal identity. You know what, that got kind of dark. Let me, Oh, there we go. All right, so to find the the reciprocal ratios, so for sine it would be cosecant of 300 degrees. It'd be 2 over the square root of 3, which we would end up rationalizing, and you get 2 square roots of 3 over 3. For secant of 300 degrees, you take the reciprocal there, you get 2. And for cotangent of 300 degrees, it would be 1 over the square root of 3, which ends up being square root of 3 over 3 when you rationalize that denominator. Whoops, I'm sorry, I went off the grid there a little bit. All right, so that's how you can use the xy axis and what we know about the 30, 60, 90 degree triangle, or you can also use the 45 degree triangle if you need to. And this angle here is what we call a reference angle. And we always use the reference angle with respect to the x-axis. And you can see the triangle I formed here to get the point here. You got to watch out with your signs too. You know the radius will always be positive, but x or y could be positive or negative. All right, let's go ahead and finish this video here. I want to talk about radian measure. In the next video, I'm going to focus on radians, or really the unit circle, and that's going to be our go-to method for finding these ratios as we head into chapters 5 and 6. Whoops. Here we go. All right, so I'm going to try to help you, if you haven't already got this memorized, I'm going to try to help you see a way that you can memorize this. Let me go ahead and focus this a little bit. All right, so the way you can get to know this, your radians really well, first of all, we know that the circumference of a circle, C, is equal to 2 pi r. If you make your radius 1, then this would be 2 pi times 1, or 2 pi. And again, I went off the grid here. This is 2 pi. So from here all the way around, that distance of the side here, or this length, is 2 pi. So halfway around would be half of that, or just pi. Another pi, and we're back where we began at 0 or 2 pi. We normally would call that 0. So next we have, and notice it's not degrees, it's just the number 0. In radians, this measure is 0. So 30 degrees is pi over 6, which is basically, isn't 30 degrees 1/6 of 180 degrees? And so we're just dividing pi up in that way. All right, so this is pi over 6. Another 30 degrees puts you at 2 pi over 6, which is pi over 3. Another pi over 6 puts us at 3 pi over 6, which is pi over 2. Another pi over 6 puts us at 4 pi over 6, which reduces to 2 pi over 3. Another pi over 6 puts us at 5 pi over 6. Another pi over 6 puts us at 6 pi over 6, which is pi. Another pi over 6 puts us at 7 pi over 6. Another 30 degrees, or pi over 6, puts us at 8 pi over 6. Notice that reduces to 4 pi over 3. Another pi over 6 puts us at 9 pi over 6, which is 3 pi over 2. Another pi over 6 puts us at 10 pi over 6, which is 5 pi over 3 when you reduce it. And another pi over 6 puts us at 11 pi over 6. And then this would be 12 pi over 6, which does reduce to 2 pi. All right, so you can see that the only, let me go ahead and circle this one here, the only multiples of pi over 6 that you really need to know are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, just those four. All right, what about pi over 4? Well, that's 45 degrees. So again, you're dividing pi into 4 equal parts. So this would be pi over 4, 2 pi over 4, but we would write that as pi over 2, 3 pi over 4. Oops, let me circle the pi over 4 here. Another pi over 4, and we're at 4 pi over 4, which is pi still. Another pi over 4, we're at 5 pi over 4. Another pi over 4, we're at 6 pi over 4, which also reduces to 3 pi over 2. Another pi over 4, we're at 7 pi over 4. Another pi over 4, or another 45 degrees, we're at 8 pi over 4. And again, that is 2 pi. So notice for the multiples of pi over 4, the ones we need to get to know are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. What about the multiples of pi over 3? That's basically 60 degrees, and notice there's 3 60s and 1 80, so we have 3 angles here. So pi over 3, we add another pi over 3, we're at 2 pi over 3, so we have pi over 3 and 2 pi over 3. Another 60 degrees, or pi over 3, puts us at 3 pi over 3, which again is pi. Another 60 degrees, or pi over 3, so we had 3 pi over 3, now we're at 4 pi over 3. Another pi over 3, we're at 5 pi over 3. Another pi over 3, we're at 6 pi over 3, which is 2 pi. So notice again, there's 4 that we need to get to know. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So notice, the way I think of it is our pi over 6 angles hug the x-axis, and our pi over 3 angles hug or close to the y-axis. All right, let's go on to pi over 2. Well, pi over 2, that's 90 degrees. Another 90 degrees, we're at 180, or 2 pi over 2. Then we're at 3 pi over 2, another 90 degrees. And then another, we're at 4 pi over 2, or 2 pi. And so all of these angles in pink are the ones we need to get to know. And if you just kind of play around with this circle the way that I did a little bit, you're going to get to know those really well. And hopefully that'll help you to remember them. All right, so that's it for this video.